let's keep on going. Now we're actually going to get into conducting a test. We're going to do the full-blown test. We've talked about the setting up the null and alternative. We talked about the p-value, but we're actually going to answer a question like you might see on an AP exam by doing a full, complete test for, and this is kind of what we've been building to all along. So let's go ahead and jump in. Anyway, here we're going to have a threshold where we reject. That's that small, what's the area of those small tails? And often that threshold alpha is the 5% level. Something that happens only 5% of the time is unusual, and we would use that as our threshold. It could change, the problem might specify, but alpha is that value that we're looking for. We're looking for, and then we're going to get a p-value, and we're going to compare the probability from our sample, our experiment or whatever, to that alpha, that threshold, that significance level. If it's smaller, if our p-value is less than the alpha, we will reject the null. If the p-value is larger, we fail to reject the null. This is so important right here. Okay. And fail to reject. That is a big deal. Okay. Rejecting the null hypothesis means there is evidence to support the alternative. Failing to reject the null means there's insufficient evidence to support the alternative. So you don't make any, when you fail to reject a null, you kind of just stop. You don't say anything. You haven't made a decision. When you reject the null, then you have evidence of the alternative. If you fail to reject the null, you kind of walk away. All right. The conclusion. So you do want to talk about it in the context. Hey, I feel there's that context again. If you're not talking about whatever the problem is about, you're not going to do well on an AP question. You're not going to do well on one of our tests. Okay. So always talk about, go back to the problem and tell me what it was about. Okay. So let's, you can, and this word right here, this is huge. This word is a no-no. Okay. Never conclude or prove the null hypothesis is true. You can't really prove anything. You want to use those wishy-washy words. Think, wishy-washy. You don't want to lock yourself into a corner because there's always that chance. I mean, something that happens 5% of the time can actually happen. It's just not very likely. It's just there's evidence. It suggests. Use wishy-washy words. Okay. So, all right. Let's. So again, small p-values. That something unusual, and that we would use that as evidence to reject the null. So, okay. And you can go back and read these. Again, we're going to be looking at, generally, we're going to say then the proportion is equal to, and then not equal to is more often what we'll be using in the AP tests. Don't often see this one-tailed. And I think that's all. You can read through the rest of these. Let's just jump right on in. Oh, and I think there are a couple things that are animated in there, but my face is in the way. That failed to animate in there, but anyway, so the Census Bureau wants to conduct an experiment to find out how many high school students have a part-time job. It's estimated that number is about 25% right here. All right, and we're not sure. I mean, I'm sure that varies, but let's just say they think it's that. She wants to compare to find out, is it 25% or is it not 25%? And they're going to use the alpha level 95 or 0.05. They're going to randomly select 200. That's our N, and finds 39 of them have a job. So we're going to be able to calculate p hat as 39 over 200. Okay. So let's look at what this would look like. First things we're going to do is check for independence. Is this random? And where do I see the word? Was the survey, or was the thing done random? It was a random sample of 200. Check. And is this number less than 10%? We have a part-time job of a large local high school. We don't know what that might mean. That would be bigger than the number that would be more than 10% at students at Lakeside. I know that, but Bryant, it would not be, for example. Bryant is certainly larger. So what we're going to do is 200 students were randomly selected. I found that in the passage, and we're just, whether we know it or not, to go on in the problem, you need to state that it's less than 10% of the school population. Okay. So, and if it's, we're just going to make that assumption. Okay. So that's for the independence, and we're going to check, you have to do independence and normal. Do we have more than 10 failures? And well, with the threshold, 25%, that would be 50 successes, or we're going to anticipate 50 students having a job and 150 not, which is both bigger than 10. So with proportions, you want that 10 successes, 10 failures, again, in relation to the number that we're dealing with, the proportion, the estimated proportion. So now we're going to set up our null and our alternative. We don't know. So the null would be that the P would be equal to 0.25, which is the estimated value. And then the alternative would be, in this case, I guess, oh, it is less than the national figure. I'm sorry, the problem did say, I was like, wait a second. She suspects her as less than the national figure. So that's where this came from. We are dealing with a one-tailed test. I was wrong earlier. Okay, so we're comparing, we're looking for something significantly lower than 25%. All right. And the question is 39 out of 200 significantly enough less? Okay. So we're doing a one, we have to name it. This is a one sample Z test for the population proportion, or for proportions, and P hat, or P is 0.25, and the alpha level is 0.25 or 0.05, and P hat would be 0.195, and we get our standard deviation. We can get that from the calculator. So now what we're going to do in the essential knowledge, we had those standards, or had that formula. We're going to do P hat minus P sub 0, and divide that by the square root of P sub 0 times 1 minus P sub 0 all over N. Can plunk that into our calculator, and this would be, and I guess I should have actually had this on here. Technically, this would be P sub 0. All right, so we're going to be doing the difference between those two. And so, back up one. We're going to take 0.95 minus 0.195 minus 0.25 divided by this whole thing, which was 0.036. And we got that standard deviation down here. We get negative 0.79, negative 0.1, sorry, negative 1.797, this number right here. Okay. And that number, we're going to figure out where that would be on a normal distribution. Okay, so we're going to figure out, we're actually going to try to figure out where our number would be on the normal distribution with a mean of 0.25 and a standard deviation of 0.0306. And when we find that out, we get that gives us the probability of 0.036. 0.036, yeah. Okay, so we were still doing the calculation, and that's our p-value. That's the probability of us getting this result if this were actually true. All right, so the probability of us getting 39 out of 200, given we were anticipating 50, is 3.6%. And since that number 0.036 is less than 0.05. That is small enough. That means we reject the null. All right, and I know it's down there below, but because we have a p-value, a probability, we did an experiment, and the probability of our experiment is less than the threshold alpha, then we can reject the null. If it wasn't, if it was bigger than, if the result of our probability was greater than 0.05, then we would fail to reject the null. But in this case, we have convincing evidence against the null. We reject the null, and that means that the proportion of students that have, then we go back to the context right here. Okay, that's the context of the alternative hypothesis, that the proportion is less than 0.25. So that alternative, I'm just going to turn it into words. You're going to end up writing a few sentences, okay? And that's, you know, unavoidable. Okay. The good news is you're not going to end up doing a ton of these, okay? So let's read the next one. So we have the National Institute of Occupational Safety and Health. Job stress poses a major threat to healthcare workers. That's probably very true right now. News report claimed that 75% of restaurant employees feel that work stress has a negative impact on their personal lives. You don't maybe have that stressful of a job, but stress probably impacts your personal lives. I know it does, but it does change differently when you have money on the line too. Anyway, managers of a large restaurant wonder if this claim is valid for their employees. They survey, oh, hey, look there, before I jump into anything, I found the word I'm looking for. I'm going to need that, right? I'm going to need that random. I know I'm dealing with 100, and this is my results. 68 said yes. So does that stress have a negative impact across life? We're going to now, we're changing the alpha level now in this problem. So that's our comparison. Now we're going to be comparing to 0.1 instead of 0.05. The problem will tell you the so that threshold. But again, let's go back to the beginning. We're going to set up the 4-part process. We got to do the random and independent. Well, we know we already have. Now, let me be honest with you for a minute. If it says do a significance test, all of these pieces are going to be met. You just have to find them and make sure you state them. But there are times when they ask you questions, can you do a test? And then you actually may find or not find reasons why you can or cannot do the test. So don't be confused by the fact that in these videos, I'm doing the test every time because I can, okay? They may not always be able to, but anyway, so independence, I want to check, were they randomly selected? Yes, the problem said that. And is that less than the employee population? And it doesn't say that they have more than 1,000 employees, but we're going to put it down and say it's less than 10% of the employee population. And we're talking about a restaurant chain here. You can say, you don't try to argue this, just say it and move on. A large restaurant chain usually has the word large there. That's kind of your signal to say it and go. All right. It's in there. It just doesn't tell me how many they actually have. So after I've done my independence, I've got my random word, I got less than 10%. I'm looking for 10 successes. So I'm going to take the threshold that they gave me that I'm looking for, which is the 0.75. And 0.75 times the number of people that I took is greater than 10. I should expect 75 successes and 25 failures. That's enough that I beat the 10 threshold at both levels. So that's enough to ensure normality. For part 2, then we're actually going to name the hypothesis and the test statistic and set it all up, set the hypotheses up. So in this case, we don't know whether it doesn't indicate a direction. In the previous one, we're showing less than 0.25. In this case, is asking He's wondering if the claim is valid, just wondering if it's still valid. So the null is that it is equal to 75% of his employees would have stress level, work stress related. And the alternative is that it's not 75% or not 70.75, where P is the proportion who say yes. We're doing a one sample z-test. So now all you have are the confidence interval for proportion and the one sample z-test. We've only got two. There's going to be more coming. So just keep a running log of all these types of tests we're dealing with. We've only been dealing with proportions. In later chapters, we'll be talking about other things. Okay. Where P is the 0.75 that we're claiming or investigating, and the alpha threshold is 0.1. It should be provided in the problem. If it's not provided by the problem, then you can do the 0.05, but typically it will be specified. The p hat in the experiment. So understand there's the theorized proportion, and then there's the result of our experiment or our trial. In this case, the p hat is 0.68. And that gives us a standard deviation of 0.0433 using the standard deviation formula. So now we can go on and calculate the z number by plugging in. Since this is a not equal to, we have a tail on either side. And so we're going to take 0.68 minus 0.75 and divide that by the standard deviation, and that gives us a negative 1.63. Then we're going to go and figure out the probability of our experiment. Right here that's the probability of getting okay, that's the probability of getting results like the manager got. Okay, sorry for the bad handwriting. But when we calculate that, we would get a p-value here of 0.1032. Okay, so what we're going to do is compare that to the threshold. And in this case, this number is greater than this number, than the alpha. So our p-value is now larger than the alpha. If it's not smaller, then we cannot reject the null. So we fail to reject the null, and we pretty much say that's it. Okay. So assuming that the 0.75 is actually true, there's a probability of getting a result like we got with about a 10.3% probability, which is greater than our alpha. So we fail to reject the null, and you don't make any conclusion, just you fail to reject the null. If you reject the null, then you can interpret the alternative. If you fail to reject the null, you say, we fail to reject the null, and you end the story. Okay. And that's pretty much it. I mean, you're not going to be doing a full write-up like 20 times on the AP exam. You're maybe doing once or twice. So you're not going to be doing this, but you are going to be doing elements of it. So the Khan Academy will take you through different elements of it. And then there will be an assignment. You do have a quiz coming up over 6.4 and 6.3. I hope that you're doing well, and we'll see you in office hours.